the quadratic function, the changes in the quadratic function actually gave us linear functions. So what we can do is we can actually draw the slopes here, and we can see that the changes in the slope of the quadratic function will actually give us a linear function. So that purple line is just my slope, and the red dots will actually plot the slope values. So there's my slope values. It's calculating slope values. So it's going to get, as I go to a slope of 0, notice that it hits the y value of 0. And as you notice that, as we plot the slope values, we're plotting a linear function. So that's the derivative of the quadratic function we calculated it. It's the derivative of a quadratic function is a linear function. So there it is. We can look at the cubic function. Okay, so if we plot the cubic function and we plot the slopes of the cubic function, so again, there's my tangent line. The red dot represents slope, so that slope value of that line is about 2 point something. And as I drag this point, it's just going to draw slope values. It's going to plot the slope values, so it's getting steeper and steeper and steeper. Okay, it's getting less and less and less. It's going to go to a slope of horizontal, so slope of 0. And as I get like this, it becomes steeper and steeper and steeper. And notice that the slopes of the cubic function are actually plotting out a quadratic function. And that's what we verified with using the limit, okay, using the Newton's quotient. And we also kind of saw this a little bit at the very beginning, where the changes in the cubic function, the changes in the y values were quadratic. So the slopes of the cubic function are also quadratic. Last one I'm just going to show you is then we look at the 1 over x function. Okay, so we did the definition of the derivative on the 1 over x function, and we ended up with negative 1 over x squared. So if I plot these values, notice that, so the red values are my slope values, so it's just plotting out values, so it's getting more and more horizontal, so it's getting close to 0. Okay, as I go this way, it's becoming more negative, it's getting really, really steep, and all of a sudden, yeah, we hit an asymptote, it's undefined. Then we start getting more slope again here. These slope values are really big to start. Okay, they're really steep here. So the y values are really steep negative, so really low. And then as we flatten it out, the slope values start to flatten out as well to near 0. And there it is. So there, once I plot that function, well, that function is what I calculated using the Newton's quotient. This is negative 1 over x squared. So this is the negative version of x squared function, which is pointing down. So there it is. There is just some ways we can justify just by actually plotting these points, the slope values. We can see that they are generating functions, and they're generating the functions that we calculate using the definition of the derivative.